Welcome to Spring LIB.
This is the answer to Chapter 31, problem number 4 from the Smith Organic Chemistry textbook. And this problem is asking us to draw a mechanism for a radical polymerization of vinyl acetate using this specific initiator that the problem gives us. And so remember, since we're talking about radical polymerization, this reaction is really going to occur in 3 parts. So there's an initiation, a propagation, and a termination. So I'm just going to label those parts with letters. So we'll call initiation I. So remember, in any radical chain reaction type reaction, the first step is the initiator becoming active. So in this case, here's the initiator that we were told to use. And these peroxide type initiators, oops, I dropped some carbons. So, oh boy. All right. So I apologize for that. So here is the initiator that we were told to use. Right. And so remember, these peroxide type initiators are popular initiators for this. The oxygen-oxygen bond is very ready to split. And so this is going to cleave homolytically. So each oxygen will get 1 electron. And so now we actually have our initiator species, which is going to be this. Where our oxygen has a single unpaired electron. And so what that's going to do is that's going to be what actually reacts with the vinyl acetate. So here's our vinyl acetate. And this unpaired electron will come together with one of the electrons from this double bond to form a new bond. The other electron from this double bond will revert to that carbon. And so that will get us to this point. So there we are. We have a free radical situated on that carbon. And so that's the end of our initiation step. So we have this actual species, which is going to participate in the polymerization reaction here. So next is going to be our propagation step. So we'll call that P. And so remember, the propagation step happens over and over and over again. And that's what makes this a chain reaction. It becomes self-sustaining. So we have our activated species from the initiation step. With a radical on that carbon. And so that's going to encounter another molecule of vinyl acetate. So here is another molecule of vinyl acetate. And just as the initiator did in the first step, This radical will come together with one of the electrons with that double bond to make a new bond, and the other electron will revert. And of course, you need to draw the fishhook arrow. The fishhook arrow with only one half of the arrowhead is the right way to draw this. So the other electron will revert to that carbon. And so now what we have is something that looks like this. And so we have the free radical situated here now on this carbon. And so that free radical is ready to continue reacting and react with another molecule of vinyl acetate, and then another molecule of vinyl acetate, and so on and so forth. So I'm just going to write, say, over and over. Right, because this propagation step happens over and over and over again, and that's how the chain grows. And so finally, to end the propagating chain reaction, there's a termination step. And so in this case, so remember there are different possibilities for the termination step of a free radical chain reaction. So basically, anytime two radicals encounter one another and react with one another, the resulting product does not have a radical in it anymore, and so the reaction is stopped. So this could be between two molecules, two lengths of polymer chain that have been built. Their radicals could react with one another, or it could be between a length of polymer chain and one of the initiator molecules that we made in the beginning, that from when that peroxide bond split. But so in this instance, just for the sake of simplicity, and so actually what I want to do is say, rather than have this be the very first part of the molecule, what I'll do is erase all of this. All right, and so instead, we'll put the squiggle there. That means that polymer is continuing indefinitely in that direction. And so we'll do the same thing here. So this is another length of polymer that's been made. And so this is also going to have acetate groups. And we'll say that there's our radical there as well. And so, as I said, what's going to terminate this reaction is the coming together of these radicals. And so, rather than reacting with another molecule of vinyl acetate, these radicals encounter one another and form this product. Oof, ugly. Apologize. Let me redraw that. So these molecules come together, as I said, and will form this product instead. And I'm just going to use OAC because it's easier than drawing acetate groups. AC obviously stands for acetate. So here's our new bond that we made from those two radicals coming together. And so there we go. There's no more radical to react, so the chain reaction is terminated. as the name termination step implies. And so that's it. So again, remember for these, for a radical chain reaction, you have an initiation step, a propagation step, and a termination step. The initiation step is when the active species is made. The propagation step is the actual reaction that's taking place over and over again to grow this chain. And then the terminal step is a radical encountering another radical rather than a radical encountering, in this example, a double bond with which to react. And so that's the answer to chapter 31.